Hello, math teachers. My name is Cole. I'm an actor as well as a dyscalculate, as well as a tutor. I will explain what that means in a moment. So, why is it so hard for dyscalculates to learn math? Let me show you. It's hard for dyscalculates to learn math because, and I'll share my screen with you in a second here, that's why I'm getting closer to the screen. Dyscalculia is a mathematical computation difference, not a mathematical comprehension concept difference. So what I'm saying is that people with dyscalculia can understand mathematical concepts, they just have trouble with calculation. So the formula that I have created to tutor dyscalculates in math, I've never tutored math, but I am a dyscalculate myself, as well as a former English tutor, is x is equal to f plus a plus v equals c. So let me write that out again. X equal sign f plus a plus v equals c. Now, if you remember, I did a video where I broke down how to do this in Excel and all of these other things. This is the TI Nspire emulator software, and I'm going to break it down in here because I think that this is a much better and easier way to do it. Okay, so X, just like in algebra, is the thing we are looking for. So the product of the thing we are looking for, right? The answer, right? So X equals the formula, which is the steps, plus A, the arbiter, so what operation we're doing, plus V, this is important, the notated value, plus C equals the conclusion or the product of X. So that can be written as C equals P of X. So that's the formula. I'm going to erase it for now. But what I will do is show you what I mean. Let's do a very, very simple math problem. 1 plus 1. 1 plus, plus 1. Now, let's see how that might work in a dyscalculate situation, right? So we've got our notated values, 1 and 1. We've got our arbiter, addition in this case. We've got our X, which is the notated product of 1 plus 1. And we've got our conclusion, or we haven't got our conclusion yet, but we've got everything we need to get that conclusion. So I'm going to press enter, which is the equal sign, and we get an n of this. Okay, we get an n of 2. All right, so now notice I said notation. The reason it's difficult for anybody, not just dyscalculates, but particularly dyscalculates to learn math, I've learned from personal experience, again, as I'm a dyscalculate myself, is that numbers have no value whatsoever. Let me explain that. 5 is only 5 because someone called it 5. the answer could have been 40 to 5 plus 5. And if someone called it 40 and everyone agreed that it was 40, the answer would have been correct. So when you tell a dyscalculate to arithmetically computate the numbers, they will give you something like this. And I'm going to do it in formula terms here, right? So we've got x plus y equals z. Now, of course, x plus y equals z is actually correct. Now, I didn't put the equal sign there, but x plus y equals z. Okay, now let's replace that z with the number 0. 0 is the only notated value that corresponds to its actual value, because 0 means nothing and numbers themselves don't have any value. So the real formula is, let me rewrite it for you. X plus y equals 0. Okay, that's what's really going on here. So when you tell a dyscalculate to solve an equation, they're not going to be looking for the assigned value, right? They're going to be looking for the actual value, and they're not going to find it because x plus y is always equal to 0. Do you understand that? Okay, good. So we're moving on. So how can dyscalculates learn math? And quite frankly, how can everyone learn math more easily? Well, by using a calculator. We live in a society where calculators are the norm. We have them on our phones, we have them in our pockets. So memorizing math and learning, that x plus y equals a assigned value of something is completely and utterly irrelevant today. That might have been relevant in the past, but it is irrelevant today. Let me explain what I mean by that. Let's take our problem 1 and 1 equals 2. Well, it's 1, the notation of 1, plus another notation of 1 equals a notation of 2. Memorizing math facts is completely irrelevant. Why? Because we have calculators that can do it. So I would rather see a teacher teach math, in other words, the tool that we use to figure out a solution to a problem, as opposed to teaching math by doing math. In other words, calculating, because math is not about calculation. Math is a tool that we use to solve a problem. Let's try another example, okay? And for anybody who is dyscalculated or anybody who uses a calculator to do math, they are not cheating. They still have to learn a procedure. Let me tell you what I mean. Let's take the example of 5 plus 5, right? 5 plus 5 equals. And so we have our notated values, our arbiter. We know what we're looking for. We have our x, which is the notated product of the addition of these two notated values. So that's, we get a notation of 10, right? And you notice that each series of buttons I press, because they're highlighted, right? It's actually a pattern. Look at this. Let me show you again. 5 plus sign plus 5. Did you see the series of pattern? So each, and we get into, so each mathematical equation can be shown in shapes. And that's the key to making math easier. Let them use a calculator. Let every student use a calculator for even the most basic equations. Things you think they should be able to do in their head doesn't matter anymore, because we have calculators and things that can do it for us. Right, let's try something a little more complicated. Okay, let's try a division problem. Now, notice the same formula, x equals f plus a plus b equals c, works for every kind of problem in every math system ever, or every math equation ever. So remember, if you let your students use a calculator, even for the most basic equation, they will learn more math. Why? Because their brain doesn't have to focus on the math itself and the calculation, but only the math itself, because they've got a calculator doing the math for them, right? Or doing the calculations rather for them, right? Let's try something a bit more complicated, right? Let's try 45 times 6 plus 9. So that is a mixed operation. And we hit our enter sign and we get this here. Okay. So we get a notation of this. This is our final notation. Whoops, sorry. This is our final notation. Do you see how they learn more math because they have to worry about the math and not the calculations? And they can worry about the math because we're expressing the values as notations, right? So they can worry about less calculation and more procedure, right? Now, of course, if the student can look at a piece of paper with a math equation on it, they can go step by step and say, well, 1 plus 4, now put that notation down, now carry the other notations and so on. So everything can be done. It's just a matter of taking the calculation away from the student and putting it on a device that was made to do it. And by doing that, they learn more math because they can focus on what they're doing and not the calculation. Thank you.